In this video, I'm going to show a way of balancing chemical equations that doesn't rely real heavily on math. Something that it's almost like using tangible manipulables, but we'll be doing it on paper instead. So it's kind of a hands-on way of balancing chemical equations. Now, I'm sure that this is not the way the top scientists at DuPont balance chemical equations. But as an introduction to the concept, then it is a really simple method. The last couple of years of teaching it this way have been really successful with students who were still developing their math skills. But this way they were able to balance the equations, and it worked out real well for them. So as an example of how to do it, I'm going to use the aluminum hydrochloric acid reaction. And you have to leave in space for the coefficients when you write the equation. So it's aluminum plus, and then the coefficient, HCl yields, and then it's AlCl3 plus coefficient H2. Now, the law of conservation of matter says that for an equation like this to be balanced, the number of atoms on this side have to equal the number of atoms on this side, and the same number of each type of element needs to exist. So mathematically you can do this and do an atom inventory, but this way we're doing it, we're going to do it with these tangible, this picture version, and also gives us an atom inventory. So we're going to put our products on this side and our reactants on this side as you normally would, and I'm going to draw the molecules out using the periodic table letters as the symbols for the molecule. So one molecule of aluminum would be simply Al, and one molecule of HCl would simply be that. Over here we're going to have aluminum and 3 chlorines as a single molecule. So we write it in like this pictorially, and then we're going to have 2 H's as a single molecule. Now, in order for the equation to be balanced, again, the number of each type of atom on each side of the equation has to be the same. We can immediately look and see that we have 2 hydrogen on this side and 1 hydrogen on this side. And we have 3 chlorine on this side and 1 chlorine on this side. So in order to get the number of molecules, the number of atoms to be the same, we have to add entire molecules. So we can't just add an H or a Cl, we have to add the entire molecule, an HCl. Likewise over here we would have to add an entire HH or an entire AlCl, So we have to add the whole thing. So in order to get it to balance, the first thing we look at, I'm going to look at the Cls. Because there's 3 of those and there's only 1 Cl here. So I'm going to have to add 2 more molecules of HCl. So make sure I write out the entire molecule, not just the Cls that I need, but the entire HCl molecule. This is the mistake that a lot of students will make, is they will need more chlorines, and so they'll just draw in the Cls, and that's not allowed. You have to do the whole molecule. Now when I go back to my atom inventory, I have 3 chlorines, 1 aluminum, 2 hydrogen, 3 hydrogen. Now I have an even and odd number situation. Now, I chose this equation because it has this even-odd complication to it. And in order to balance it, now if you do this mathematically, you start thinking immediately, I got 2s and I got 3s, what can I find that'll give me? But if we're just going to do it graphically this way, well, I have 3 hydrogen here, 2 hydrogen here. I need more hydrogen on this side, so I'm going to add another hydrogen molecule. Now I've got 4 hydrogen and I've got 3 hydrogen. I go back to this side and add another molecule of HCl. So I have 4 and 4. Now some people have already jumped ahead and they've seen the solution a couple steps back, but if you haven't jumped ahead and seen the solution, the next thing you do is you say, well, I've got 4 here and 3 here, I need more on the product side, and I have to add an entire row. I can't just add the 1 Cl, so I have to add the entire row. So it's Al, Cl, Cl, Cl. Back to inventory time. I have 6 and 4. I have to have more on this side. So I have to have 2 more CLs to get that to balance. So now I have 6 CLs and 6 CLs. I have 2 aluminum and 1 aluminum. So I'm probably have to do something with that. But because it's a singleton, I'm going to wait and do it last. But I've got 4 over here and 6 over here. And obviously, by now, you've jumped ahead. You've seen this solution. So now I have 3 rows of hydrogen, 6 rows of hydrogen, 6 rows of chlorine, 2 rows of chlorine. Now, if I do atom inventory, it's 6, 6, 6, 6, 2, 1. But because aluminum is a singleton, all I have to do is add in another aluminum. Now, what are the coefficients to the balanced equation? Well, all you have to do to find the coefficients is count the rows. And I'm going to use a different color. So I have 1 row, 2 rows, and that's going to give me a coefficient of 2. And here I have 6 rows. 1, 2, 3, 4, 5, 6. That will give me a coefficient of 6. Here I have 2 rows. 1, 2. That will bring in the coefficient of 2. And then here I have 3 rows. 1, 2, 3. And that's going to give me a coefficient of 3. So this method graphically allows you to come to that balanced equation, and it's very tangible for people who are first learning this. They're able to see and they're able to connect the coefficient to the rows, the chemical notation to the molecules that they represent. So the AlCl3 is the Al with 3 Cls, H2 is 2 H's. So we connect the subscripts to the molecule, the coefficient to the number of molecules. So it does give us a very solid, very tangible way of doing this type of balancing. And it also works for polyatomics, but with polyatomics, you end up having to keep the parentheses, and so you could reduce it or do some other things, but this way makes it very visual. I have 3 SO4 molecules. So there's 1 SO4, there's 2 SO4s, there's 3 SO4s. In this case, the coefficient was 1. But if there had been another molecule, it would have had to have been Fe parenthesis, and then the whole SO4 3 times if you had another version of this. But this method will work. It may not be the orthodox method, it may not be the fastest method, it certainly uses a lot of paper, but as a tangible way of balancing chemical equations, this method will allow young learners the opportunity to have sort of a tangible experience and be able to get that balanced equation. So if you're new to chemistry, try this. And as you try it, it'll become easier and easier as you go along. So that's it on balancing chemical equations. Thank you for watching. If you liked this video, please click the like button. Also, consider subscribing to the channel. And there's lots of science videos in the World Around Us playlist. Check those out. And otherwise, again, thank you for watching.